Hello, everyone. Sorry for the late introduction. We had some issues with the link to access, so we are starting now. First of all, thanks everyone for joining us today to this TechTalks series. Today we have a special partner invitation. We have Anne Lakbai from Henkel. She's joining us today to present us an interesting presentation about resins and why to use them over thermoplastics. So she will go in deep about these materials and how to use them and some case studies about them. Before we start, I just want to remind you some rules. First of all, we will have a Q&A session at the end of the webinar. You will be able to see in the upper tab button where you can post your questions, and at the end of the session we will reply to all of them. We will have 5 minutes for that, so please feel free to write down your question during the session. If we are not able to reply to all of them, don't worry, we will reach to you with some replies and we will go in deep later on after the webinar. So welcome again to Anne, and I leave you the stage over so you can present us this interesting presentation.
Thanks for the introduction, Angelica. And hi, I'm happy that everybody is here finally. I'll start sharing the presentation in another mode, so it's better I can interact with you. I will talk about, as Angelica said, about the Loctite 3D printing resins. I will start with Henkel, who we are and how 3D printing is going to be inside. So we are divided into adhesive technologies and consumer brands in Henkel, and the red line there is cleaning. And from a chemistry point of view, we fit in well with Loctite, so that's why we are Loctite 3D printing. And of course, in the resin world, we are cleaning as well. We have several technologies. 3D printing is one of them, and we can easily access the others because, yeah, we're in the same setup, let's say. This also includes automotive parts. What we do is we do resins for DLP and LCD screens. Sometimes they're also called MSLA. What is special about it is that we're thermosets, and some others use also thermoplastics. Then these resins are high performance resins that are working on those set technologies for production and prototyping. And it started in the dental market and now transitions into the industry, e.g. the automotive industry. Why? The reason is the accuracy we can get, the high performance of the resins, and the economics, because you can print in a fast manner with the DLP and LCD systems. And all the knowledge we have, we combine in the loctiteam.com. So a lot of things that I'm going to talk about is also visible on the webpage. And now we come to the resins that we have. We have functional materials and prototyping materials. The functional materials are subdivided into high performance, high impact, high temperature resistance, elastomeric, and also healthcare resins. The healthcare resins especially have several certificates, and also others can be safe to touch, for instance, and the variety goes from safe to touch to extended biocompatibility. But details on it are also found on the respective TDSs. Okay, so I want to spend some time to talk about on the workflow validations and the durability, because that leads to the comparison of the thermoplastics. So we combine in a workflow the material, the printer, and the post-processing, which is cleaning, drying, and post-curing. And then we check if we have, with this workflow, achieved the data that is on the TDSs. If so, that is called a validated workflow. We can do studies on it, like the durability studies. We have accelerated weathering using UV light. We have chemical resistance, accelerated heat aging, climate cycling, tensile tests between -40 degrees C and 100 degrees C, and also salt spray exposure tests. This durability program uses the validated workflow and has it divided in a more organized manner, because every durability aspect is coming from one print, has reference samples and aged samples, and are processed in a standardized manner. We have for most of the tests weekly testing, and for the chemical resistance, we have 24-hour test and 7 days test. We test in several ASTM standards depending on the resin itself. And to summarize it, we have several aspects of durability and having all respective standards, doing mechanical property tests, and at some points also mass change tests. And then, like I said, 6 weeks in 1 week intervals, or 1 week and 24 hours for the chemical resistance. And this leads to the possibility to have your application chosen for the right material, or the other way around, the right material for your application, depending on your point of view. That means, for instance, with this application, we used 3843 and had it, because of its nice durability testings, we made samples of it for automotive parts that needed a durability test themselves. So this resin printed part needed to withstand all the aspects of the automotive industry durability test, like humidity, wind, dust, and temperature, and sometimes also a combination of it in a cyclic manner. Having said all this, in automotive, usually you have thermoplastics, and usually the question is, how does it compare? That's the most interesting part. So we chose to run PA6 against 3843 plaque and POM against IND43. And I have brought the example of UV aging with me. There is a white paper on it in this quarter that will give more detailed comparison between several aging studies we did. So we see here running POM against IND43. And with the Young's modulus, you see that they're performing similarly. For the elongation at break, the performance of IND43 is slightly more stable and a bit higher, because it will degrade only after 3 weeks. The POM is degrading after 1 week already. For the stress at break, we will have the same performance, which brings me to my next point, that the yield point is not there in POM. That's why we cannot compare it. So that's not because it failed at all, but it's a different characteristic. So we can only compare the things that we have. Then the PA6 against the 3843 is looking a bit different there, because we have the PA6 degrading a bit faster than a 3843. So you can say that this thermoset is outperforming the thermoplastic. That was a bit unexpected, but we love it. So basically, in every category, like Young's modulus, elongation at break, stress at break, and stress at yield, the performance of the thermoset is better. So, okay. So this is the end of the presentation so far. I wanted to leave some space for your questions because it's nothing more important than answering the questions on hand.
So please, if you have any question, write it down in the Q&A tab.
I see a question here in the chat function, which is okay. I can not really comment on that openly because we have a separate sustainability department that is taking care of the sustainability aspect of everything that Henkel does. And I will give you the contacts and then we can, you can reach out to there. I'm sorry that this is kind of a short question to your answer, but yeah, that's the regulations. I'm sorry about it.
We have got another one on the Q&A.
Yeah, sure. Well, it always depends a bit on what so I will probably read out the question first, sorry. So which are the resins that perform best at low temperatures like minus 20 degrees C? So there is always a change. I don't want to say better or worse because it's mainly different. The test at different temperature is not there to say it's a good test or it's a bad test. It's just the performance of the resin at that given point. Usually the elastomers have an unexpected twist to them because actually you would think that they get more rigid and then break, but they perform more like a tough material than in these regions. So if you want to go to minus 20 degrees C or minus 40 degrees C, it's also a consideration to have an elastomer in the choice, or it is also calculatable if you see the percentage on the screen on the TDS, and then you will be able to calculate back from the TDS value that you see which mechanical properties, for instance, that mean, and then you can see if that is enough for your application or not. I think this is the best way to go. And all the durability studies data is published on each TDS.
Okay, thank you. So we have got another one. I don't know if you want to read or.
Yes. I would say which are the resins that no, this is not already
no.
the one above. Okay.
Yeah, above.
In the automotive sector, there's a wide use of PA with glass fiber, which is the resin that can get close to that. Okay, I think this question will have more thought on it. So I would like to have like a product name or a TDS if you have it on hand. That you can send out to me. I think Angelica can forward my email address to you, and then you can contact me via email. And then I can sit down a bit and do some comparison, and then I can answer to that question. I think this exceeds a bit this Q&A section here. Then, what printer features enable it to print a specific resin? Light wavelengths, for example. For our resins, we usually can print them at 385 nanometers and at 45 nanometers, which is debatable. The technology is important that you use either DLP or a LCD system or a /MSLA system, how they sometimes call it. And then you will be able to print For instance, on our TDSs, we also have a workflow that includes ECDP calculations, also a starting point, what we use to print, and also a theoretical starting point that you can use to print. And on top of this, we have on our webpage, loctiteam.com, a section where we have already validated workflows that you can choose per machine, resin, and post-processing method. And then you can download a recipe-like PDF that you can follow the steps to get your printed part. So the next is reading, is there any resin that can be used to produce molds for plastic injection in order to make small series? Yeah, we have also some examples on our webpage. We have IND 147, sorry, that is printed to have a blow molding mold, and Pepsi uses it for shorter iteration, and it can also be used as a part. It can be injected with 10,000 shots. And the other example that springs to my mind when I read it is the IND 43 that can make molds for low pressure molding.
Okay, so I don't see any more questions. I don't know if anyone has anything else to ask. So we still have a couple of minutes.
There's the next question. What about food contact on the resins? I make a long story short. I think we're working on it. And stay tuned on loctiteam.com and see the updates.
Okay, so I think for today that's all. If you have any more questions, you can please reach me out. You can write us to info@makeadditive.com or to my email agarcia at makeadditive.com. So you can ask as many things as you want, or we can give you the presentation and the contacts for name, so we can go in deep further. Thank you everyone for joining us. Thank you, Anne, for joining to this TechTalks series. We are happy to have you here, and see you everyone next time. We will have another webinar next Wednesday at the same time. So if you are interested, I'll see you there. Thank you to everyone. Thank you, Anne.
See you. Bye.
See you. Bye-bye.